Good morning to all. Myself, T.K.Madhu, Selection Grade Lecturer, ENC Department, Government Polytechnic, Tarihal. So today we are going to see the basics of NodeMCU and how to interface to the IoT. And before going to that, we have to see the features of NodeMCU and the pin diagram. And slowly we'll do a simple program where using NodeMCU we are going to do the program for blinking. Later on, slowly we'll step into IoT programs like creating a dashboard and with the help of web server and creating a dashboard. And if you click on the dashboard, the different devices can be made on and off.
Now we shall see the basics of NodeMCU ESP8266, that is inbuilt Wi-Fi module pin diagram. So here if you see, this is the SMD board of NodeMCU. Here we can see VCC. So this board is working for 3.3 volt. So it has been given the more than 2 places, because when you are doing PCB it will be convenient for taking the layout drawing. So they have provided more than 2-3 places they have provided the VCC. So this we are going to use VCC of 3.3 volt. And coming to this digital pins, so here they have named it as D0, D1, D2, all the pins which are denoted with the help of prefix D and the suffix with the number. So these represents digital pins. So with the help of these digital pins, we can make it as input port or output port, and we can write the program for the particular application. Coming to the analog pin, here we have only one analog pin, that is A0. So whereas in Arduino we have many analog pins, whereas here in NodeMCU we have only one analog pin. Then coming to the UART, that is nothing but serial port. If you want to interface any Bluetooth or any GSM modem, there we have the UART by name RX and TX. So here we have RX D0, TX D0, then TX D1 and RX D1. So we can interface, there are two UARTs in this. We can interface like one with the Bluetooth or one with the GSM modem, like that. Then coming to this SPI, serial peripheral interface. So we have serial peripheral interface, so which is similar to UART only. And we have I2C. So here you suppose if you want to interface an LCD, and then LCD requires 8 pins, so to send the data. Instead of that, if we use I2C, with the help of a single line we can interface LCD and we can save lot of pins. Like that, for any serial interface we can use I2C. So here in the box they have given what are the features are there for this NodeMCU here. So we can represent the power is given with the red color, similarly with the different colors of all the pins: analog pin, system, UART, ground, SPI, I2C, others, and chip name, that ESP8266 pin. So remember this ESP8266, when you are selecting the software, we have to select the chip by name ESP8266, and there is GPIO pins. So if you want insert SD card we can do, and if you want to control the speed of the motor, there is a PWM is given, inbuilt PWM is there. And here once again you can see features of NodeMCU. So they have given a chip number, and the working voltage for this NodeMCU is 3.3 volt. The regulator has been shown in the board, and this is flash button. So sometimes when you are downloading the program, we may need this flash button. And there is a micro USB port. So micro USB port means, so just for like a mobile, not the C port, a small mini C port, directly that mobile charger, with the help of mobile charger we can provide power supply to this. and there is a reset button. So when there is any stuck in the program or you want to reset immediately, just by pressing this, your NodeMCU microcontroller starts from the beginning. And there is an inbuilt antenna. So the antenna capacity they have given for 2.4 gigahertz antenna, and there is an onboard LED. This is very useful to do a basic program for testing this NodeMCU onboard LED, which is connected to D0 pin. So here USB to TTL converter is there. Now to make easy for the students, let us start a simple program, that is using NodeMCU. Using NodeMCU, we have to blink the LED. So here better not to go to IIoT immediately. Just do the simple program, then we can go slowly to the IIoT programming. So here you can see the experiment number 1, we have made it. Circuit diagram of NodeMCU interface to LED. So we have put a block, and no need to show the full diagram, just represent the ports which you are using. So the important thing what I want to tell in this, see in the Arduino we used to use the pin numbers 2, 3 like that. Whereas in this NodeMCU we can use, in the writing the program, we have to represent the pin numbers as D0, D1, D2, D3, D4. So D5, D6, D7 like this. And if you are using analog pin, then you have to write A0. So here they have given two options to us. One, to use these digital pins directly in the program, or we can use this GPIO 16 or GPIO 5. These numbers like 16, 5, 4, 2, 14, or these pins also we can use. But for the students, if you use GPIO numbers, it will be more confused. So better have a practice of using these digital pins directly like D0, D1. So here the similarly we have written for this program. See, I have made it here D0. So in the program also we'll use D0. So here D0 is connected directly to the LED anode, and cathode is connected to the ground. So program to blink LED using NodeMCU ESP8266. So as usual we are writing in Arduino. So the first step, void setup, and the parenthesis will start. Now here we are writing the instruction pin mode. So this will decide whether you are using D0 as an input port or output port. So here we have written D0 comma output. So we are initializing digital pin D0 as an output port. Then the parenthesis closed. So void loop, that is this loop means the represents continue forever. The program of writing this loop, the program continuously it executes in this. So digital write. So here the parenthesis is opened. Again we have written digital write D0 comma high. So here we can write high, or we can represent, instead of writing HIGH, we can put only 1. So D0 comma 1 also we can write. So we have made D0 pin high, and we have given a delay of 1000. 1000 means here it will wait for a 1 second. And again digital write D0 comma low. Now D0 will become low. Again it waits for 1000. So here it is shown 100. Better you write it for 1000 only. So 1 second delay will be given, and parenthesis closed. So once if you execute this or download to the NodeMCU, the whole this loop will be continuously executing. So this is the program for blinking. So when you buy a NodeMCU in the market, directly if you do IoT application, if the board is not working properly, you will not be knowing that. So better download this program, blink program, and there is an inbuilt LED in that. It starts blinking. Then you can decide that this board is working fine, and you can go with the further experiments.
Now I'm going to show in the real time by uploading the program Blink LED to this NodeMCU ESP8266. So now I'm going to connect mini USB cable to this USB to the laptop and mini USB to the NodeMCU. Now I'm going to download the program. So this is the upload button. Clicking on this, now the program is getting downloaded. Now we can see the blinking of LED in the microcontroller NodeMCU.
Now we shall see in IIoT lab for 5th sem students, experiment number 2. Practice Introduction to NodeMCU ESP8266 Wi-Fi module and its simple implementation. They have given simple application or simple implementation. So here we planned, for example, to make light, fan, bed lamp and AC on and off using IoT dashboard. So here there are 4 loads we have taken. So here we can see 4 loads of any kind you can connect. So here we have taken as an example light, fan, bed lamp and AC. So kit requirement. So we need a NodeMCU ESP8266 and we have to use opto isolator, driver circuit and relays. So here it's a very important note that without opto isolator, better don't connect your laptop or desktop. Sometimes it may harm your laptop or desktop. So I'll explain that how it harms in the later slide. So this is the block diagram to implement that IoT platform to make some of the loads on and off. So here we need a Wi-Fi for this board, or we can use hotspot also. So I have shown a Wi-Fi is required. Then the block diagram is here. So NodeMCU ESP8266. This is a microcontroller inbuilt with Wi-Fi module, and then output of this we have to connect to the driver circuit with relays. So here the driver circuit will consist of optocoupler and Darlington amplifier. Then along with that 4 relays will be there. So the output of this we are connected to the loads, 4 loads. So here we have shown only one due to the space constraint. So we can use 4 loads here. So whenever you download the program to this, then the output of ESP8266 will be 3.3 volt, which we cannot drive these relays. So by using this driver circuit, this will increase 3.3 volt to 5 volt or 12 volt as per the relay specification. So output of relay, that is with the output of relay contacts, we can give power to the 230 volt loads. So here the block diagram of NodeMCU is explained. So where the students can write in the journal directly seeing this. Then we have given about the driver circuit with relays. So just now we explained the output of NodeMCU is 3.3, where we can increase it to 5 or 2 volt. Then relay. Relay is a switch, electronic switch. So just it will make on and off, and it will supply power to the 230 volt. And loads. So here whatever the output we are connecting, that has been mentioned here. So here after downloading the program to the IC, then you have to open the serial monitor, which I am going to show in detail. You have to open the serial monitor. In the serial monitor, you will find this IP address. When you execute the program in the Arduino IDE, once the program is downloaded to the IC, you have to click on serial monitor. Then the IP address will be displayed on the serial monitor. This IP address you have to copy to the URL of, in the Google you can go and you copy in this URL. So now this will be connected to the web server and you'll get the page like this. So you'll find the web server dashboard. This we call it as this part here to here. We call it as a dashboard. So by clicking on this on or off, the relay can be operated. With the help of relay, we can control light, fan, bed lamp, AC anywhere from the world. So this we call it as a dashboard. So by clicking on these above software buttons, one can control the different devices through IoT. So this is very quite interesting. Try to do this basic program. So then you can use Blink app IoT platform. So here I want to show simulation of how optocoupler driver circuit relays are working. Now, so directly never interface your laptop to the NodeMCU. Sometimes if the students do any small mistake, so there will go reverse voltage your laptops or desktop, and that part of section USB section will be spoiled. So better always output of NodeMCU you have to use isolation, that using optocoupler, then your laptop and desktop will be safe. Make a note of this. So this circuit shows how the output of NodeMCU is connected to the driver circuit and relays, and how we can drive the 230 volt load. Here we used driver circuit as ULN2803, or we can use ULN2003. Suppose if you are getting 3.3 volt, which has to be considered as 1 from the node MCU, that is fed to the pin number 1. So now this ULN2803 consists of Darlington amplifiers. The output of pin number 1 will be getting at pin number 18. The 18 we will have 12 volt. Suppose if you are getting high signal here of 5 volt, and at the 1C, that is a first transistor collector, you will get a ground. This is ground with respect to the voltage 12. Now this relay will be energized. Now the contact whichever is connected to the NC, so this we call it as common terminal. This is common, here also it is common, this is also common terminal, and this is the fourth relay common terminal. This is NC, normally connected. This is NO. So whenever relay is energized, the common terminal which is connected to NC will be connected to the NO. Then you can see the closed path for this like this. Now this bulb will glow. So we will see with the help of animation. Suppose if I give 1, now you can see the relay contact which was connected for NC, now it is connected to NO. Now the bulb is on 230 volt. So in the place of this, we can connect AC or any, depending on the load requirement, the relay specification you have to choose, and we can connect any kind of 230 volt load. So again by clicking on this, it is off. Again clicking on this. So here you can see the bulb is glowing, the animation of bulb glowing also it is representing. Similarly, if I want to drive one more channel, one more load, I will make this high. Now you can see this load is on. Similarly, third one, fourth one. So now all are on. So this is the 230 volt. Even here we can see that 230 volt is on in the animation. And if you want to make it off, so here you should think that whatever these zeros or ones, which is going to come from the output port of NodeMCU.
Now I'm going to show in real time downloading the web server program to the NodeMCU, and by clicking on the serial monitor, and we have to copy it in the URL, then the dashboard will be created. By clicking on that, I want to show the light and fan will be made on and off. Now I am going to upload the program to the NodeMCU. After uploading, we have to click on the serial monitor. So by clicking on this, you can see the IP address here. So this IP address you have to copy in the URL of the Google. So here I copied. So we got this dashboard. So this we call it as a software buttons, or the whole screen we can call it as a dashboard. So by clicking on this, you can see the light is on. Again, by clicking on this, the light is off, on, off. So now I'll make the fan on. Now I'll make both light and fan on. Kindly note this board consists of NodeMCU, and there is a optocoupler, driver circuit and relay. So we should not use direct interface to the laptop, direct interface. So we have to use with the help of optocouplers. So if any short circuit, or if the students do if any mistake, the high voltage will not fed back to your laptop USB port. If you don't use optocouplers, there is a chance of damaging your laptop.